So next, in order to define a matrix, so let us say I want to define a matrix called stress. Then what I have to do is, for the row it is comma, right? So let us say 1 comma 1 1 comma 1 2 comma 1 3. Let's say these are the first row entries, semicolon. Now I'm moving to the second row, 2 1 2 2 2 3, semicolon. Third row, 3 1 3 2 3 3. Okay, so then I have a stress matrix with these entries. So again, as you can see, you have to define numbers. But one major difference between Octave and some other languages like Python, C and all that is that you can directly go ahead and define a quantity. You don't have to state beforehand whether this is a scalar, this is a means whether this is a string. You don't have to state all that. You can just go ahead and define the quantity. Next, this is one way of definition. Another way of definition is, so let us say initially I want to simply define a zero matrix. So I can say I of 3. Okay, that gives me an identity matrix of size 3 by 3. One difference between MATLAB and Mathematica is that in MATLAB or Octave, the functions start with small letters. In Mathematica, they start with capital letters, and we use this kind of a bracket over here in order to define a function. So identity matrix is one type. Another type is a zero. So if I say zeros of 3, it gives me a 3 by 3 zero matrix. So let us say I want to define a position vector, a column position vector of size 3 by 1. So then I say zeros of 3 comma 1. So I use this zeros function in order to initialize my matrices. Initialization is very important. Okay, so why do you think initialization matters? Can anyone answer from the perspective of, let us say, a global stiffness matrix? Okay, we haven't yet gotten there in the course, so maybe you cannot guess. The thing is, particularly in finite element method, you will be dealing with lean matrices, meaning in a matrix most of the entries will be 0. Okay, so in such a scenario, you do not bother about defining each and every entry, but rather you define only the non-zero entries. So for that, you first initialize the whole matrix to 0, and then you only talk about the non-zero entries. Okay, so fine. So this is about position vector. Now in order to do multiplication between a matrix and a vector, so let us say I want to multiply the stress matrix which I have just defined, okay, which I have just defined with let us say a a column vector of 1 2 3. Okay, so what happened? Stress I defined it to be 0. Let me, you can use up arrow in order to bring up the earlier commands. So this is stress, and then again I'm pressing up arrow twice in order to get this. Okay, so now in MATLAB or Octave, you have to use star in order to specify multiplication between a matrix and a vector, or a vector and a vector matrix multiplication. You have to use star. Okay, then of course here you do not have this differentiation, integration, all that analytical stuff you do not have. If you want to do multiplication of okay, so there are two kinds of multiplication between vectors. So let us say I have two vectors. Okay, so A is 1, 2, 3, and B is, let us say, 4, 5, 6. Okay. Now if I want to multiply a specific entry in A with the corresponding entry in B, then I do like this: A dot star B. Okay, what it does, this dot star does, is it takes the first row first column in A, multiplies it with first row first column in B, so that is 4. Then second row first column in A with second row first column in B, which is 10. Third row first column, third row first column, which is 18. Okay, so dot star is another operator which we use. Just give me a second, I have to connect my power cord. I'm in a class, I'll call back later. Alright, next next. So I have taught you two different ways, right? Whenever we are plotting, we want let us say one variable like x from one point to another with some increment. So the way we do that is, so there is some option called x equal to, let us say, 0 to with an increment of 0.1 to 1. So if you do that, then what happens is you create a x vector starting from 0 with an increment of 0.1. Okay, then I can go ahead and create so let us say I want to say y is sine x. Okay, or let us say sine pi x. Pi is a defined variable, so I can say pi star x, let us say square, but then I have to do dot exponent. Okay, then that is y. Okay, sine pi x square, and then I can go ahead and use my plot function. So I can say plot of x comma y comma, let's say red comma, this line width is in MATLAB, comma 2. So then it creates a so this is sine pi x whole square from 0 to 1. Okay, so this is how I can do plotting. Do plotting. So now once you define a vector, so let us say we have defined stress was this. Now let us say you want to call one particular entry, then how do you do it? So then you use these brackets and then you say, let us say 1 comma 2, in which case it is 12, or let us say 2 comma 3, it is 2 3 23, and so on. Okay, what else would you like to know? Sorry. So until now we have been talking about how to learn things, how to use the command window. But you cannot write a whole program in the command window. So for that you make use of the editor. Okay, so you can go to something called editor. Now in the editor, you can first thing is you have to save your file. So let us say I am going to save it in some folder. The MATLAB and Octave programs have an extension of .m. So let me say I'm calling this as temp.m. Okay, so fine. So it's temp.m. Now here you can write whatever code you want. So let us say a equals to 2, b equals to 3, C is equal to A star B square something. Okay, and then once you have written the code, to execute the code you can either press this run button over here, save file and run, and then once you run it you can go to the command window to see what's the generated result. So now see, A is 2, B is 3 and C was A square, which is 4 times B means 3, 4 times, no, what was the thing, it was AB square, sorry. So it is 2 times 9, 18. Okay, so you can create your programs in the this thing. Now you remember that earlier I have created all this programs. So for example, for this vibration modes I have written this code. So you can take a look at these codes in order to understand how different things are done. One more small point is, whenever you want to write a comment in MATLAB, it is simply you can put a percentage symbol, it will start in green color and then you can write whatever you want. So for example, here A is density in kg per meter cube, something. So whenever you are writing a code, it is very important to write comments so that anybody reading it would understand what is going on. Okay, so yeah, you can take a look at these programs that I have already shared with you in order to understand yeah, how exactly you can use MATLAB. Okay, please